Good morning. Hey, Justin. Let me just pull up Google Classroom super fast. Okay. Good morning. Delicious. Let's start at 10:05, right? Let's give everyone enough time to start. And the do now is to draw the following circuit. Okay? Where's my marker? What the heck? Oh man. You know, for living in a small apartment, I lose things way more often than I should. Here we go. Okay. Okay. Good morning, Sarah. Good morning, Atune. Good morning. So here's your do now. I wish I drew it a little neater. Okay, but there it is. Grandmaster Itamar, very good to see you. Grandmaster Chris, I'll be back. We got 2 more minutes, all right, until we. It's up to you. I thought the homework was quite simple. Not simple, but straightforward, I would say. Well, no one's really saying anything. But I guess I can take a little bit of time to. Why is the camera angle so? It should be there, and then this should be. There. Okay. We can go over the homework. All right, so. We'll return to that do now in a bit. Okay. What a beautiful day. Okay. So the homework asked, assuming my voltage source is constantly at 120 volts, as if it was designed to, what is the resistance of a 25 watt bulb? Really? What is the resistance of a 40 watt bulb? Right, and we're calling these 25 watts, 40 watt bulbs. Anytime you see a wattage, remember, right, when we learned yesterday, it's always in quotes because the wattage assumes a certain voltage, right? All right, so if I have 25 watts, I'm going to call that V squared over R. And so this is 120 squared over R. It's 25. So my resistance is 120 squared over 25. Oh goodness, I really don't want to do this, but it's around 400, right? Let me really quickly put it in Wolfram Alpha. It's 576. And very similarly, you can do similar math to the 40 watt bulb. And you will find that the 40 watt bulb is 360 ohms, right? So at least, now, do we have a rule here? Do we have that lower resistance things always have higher power outputs? No. When placed in parallel video, but when placed in series, right? What happens if I put a 576 ohm thing here and a 360 ohm thing here? And remember, this was the 25 watt bulb. This was the 40 watt bulb, right? Which one has the greater current? They have the same current. Which one has the greater voltage? The higher resistor one, right? So if I'm looking at either I squared R or IV, I know the V is larger. This is larger for a larger R. This one actually has a higher power output than this one, even though it's a 25 watt bulb and a 40 watt bulb, right? Because they're in parallel. And our wattage ratings always assume things are in parallel and not series. Yes, the one with more resistance has more voltage. Exactly. Right? So if I do IV, this, if this P, if P is I squared R or IV, then I know the power is going to be greater for this one, even though it's labeled as a smaller one, because when they're in parallel, you see, this is 576 ohms, this is 360 ohms, right? It's clear to see they have the same voltage. Which one has the greater current? This one. So if I use P as IV or V squared over R, the lower resistor one has a larger power output this time, where this one had a larger, right? That's exactly what the mini lab was about. Good morning, Jacqueline. Okay. All right. So, I mean, that's just a quick review of what we've already gone over. Right now, I want to spend some time actually solving the homework. In Morocco, the standard voltage across the battery is 220 volts instead of 120. So if I brought over an American 25-watt bulb, which is not a real 25-watt bulb, right? It's really a 576 ohm resistance bulb, right? What would the power output be in Morocco? I don't know. It's 220 squared over 576, right? We can do that super fast, okay? And it's around 84 watts, right? So it's nearly 3 times brighter in Morocco, and it's going to be 3 times hotter in Morocco than it would be in the US, which is why I don't plug in US stuff in Morocco, right? That'd be very dangerous. The 40-watt bulb, which is 360 ohms, is very similar math, and it becomes an 134-watt bulb, right? In Morocco, right? So the 40-watt turns into the 134-watt bulb in Morocco, right? So in Morocco, it would be a 134-watt bulb, okay? Last question. On your return to America, you decide to change things up again. You connect the 25-watt bulb and the 40 bulb to a standard 120 volts, but I connect them in a simple series circuit together, just like it's shown here. All right, so I've drawn the circuit diagram, already did that. What's the voltage drop each bulb? Okay, well, I know they add to 120, right? They have to add to 120 because I gain 120 here. What's the actual thingy thing? Do I really want to do this? I really don't. Okay, are you guys get, the total resistance is 936. So my current is going to be 120 divided by 936. And I'm going to multiply that by 576. So this one has 73.85 volts, which would make this 46.15 volts. Okay, so now I know they both add to 120, and the thingy thing, okay? Yes, because as Jacqueline said, you would solve the current being 0.13 if my total resistance is 936. All right, what is the actual power rating of the bulbs when placed in this circuit? All right, well, since Sarah said that the 0.13 is the current, amperes, all I have to do is multiply this by this, this by this, power equals current times voltage, and I'll get around like 7 watts, and then this is around like 4 watts. 5 watts, right? So this is around 5 watts, and this is around 7. No, this is around 7.7 watts, right? Super ballparky, like it's just around there. I don't really want to do the super math for that, okay? All right, any questions? All right then, let's keep going. And let's go back to, okay, today's actually going to be a shorter lecture. We're going to relax. No homework, no classwork today that's due tomorrow, right? This is it. I'm telling you, this bulb is brighter than this bulb. So I have 3 bulbs, okay? 1, 2, 3. All right. I want while the switch is open, all right. Which bulb has greater power, right? Rank the power output of each bulb and rank the resistances of each bulb. I don't know the resistance of R3, but I should be able to compare R1 and R2. So, and then I want to compare R1 and R2, right? So rank the power outputs, that's P1, P2, P3, and also rank the the resistances as well, right? I want you to spend around a minute on this, all right? I'm going to be back with some tea. Don't type it in the chat until I tell you because you don't want to spoil it for your classmates, okay? And you always want to be thinking about why, right? It's not enough to say like, oh, like resistance 1 is blank compared to resistance 2. I want to say why. Like, what evidence do we have for saying these things? Yummy. All right, so first thing in the chat I want to know is which one has the greater power, right? That one's the obvious one, right? I've even drawn it, right? I'm like, this has much bigger, it kind of looks like the PhET simulation. I tried to make it look like that, right? And this one is a small one. So in the chat, which one has greater power? And then from there, you should be able to use that information to tell me which bulb between 1 and 2 has a greater resistance. The second one has greater power, exactly. So how do I use that information to prove which one has a greater resistance? So Chris, Jack, Damon, Yona, we're all saying that bulb 2, Tune says bulb 2 has the greater resistance. Why? Why do I know bulb 2 has the greater resistance? All right, so Chris has an explanation here. Marcelo, nice to see you, Marcelo. Wow, I haven't seen you in forever. I also need you to turn in the worksheets, okay, buddy? If R1 and R2 are basically in series, because R2 is brighter, has greater power. Oh, wait. Everyone read Chris's statement, all right? So R1 and R2 are basically in series, and because R2 is brighter, it has greater power. And since one of the formulations of power is I squared times R, if they have the same I, the one with the greater power has the greater resistance, R, okay? The other way of looking at that, you could still use the traditional P equals IV formula, right? P equals IV. They have the same current. Which one has the greater drop in voltage when they're in series? The greater resistor, right? That's something we've already proven, right? That was like one of our reflection assignments, remember? Two things with the same current, the greater resistor always has the greater drop in voltage due to Ohm's law, right? V equals IR, same I, different R's, different P's, right? Okay. Now, why are so many of you so keen to say they do not share the same current? They do, because this switch is open. Whenever I have an open switch or a broken portion of the circuit, it's fair to assume no current goes through there. So if I have like 2 amperes here and 0 amperes goes here, well then 2 amperes does go through there, right? So it is as if, Chris, your original assumption is correct. It is as if they were in series. Okay, yeah. This switch is broken, right? It's open. Yeah. So, and I said it here. Switch is open. Okay. Ah. All right. Gotcha. What up? I tricked you. Okay. So here's our next step. All right. I then close. I then close the switch. All right. This is all we're doing. It's a pretty short lecture today. We're going to solve this. We're going to describe what happens here. And if you can do this, then you completely understand circuits and you're good to go. All right. You would have been good to go. You would be good to go for the old AP exam that would have included circuits, but it doesn't, which is why you shouldn't take it, because it's a dumb exam. Anyways, save some money. What is it, like 80 bucks? Put that to better, buy some tea. Capacitors are not on the AP1 curriculum. Right? They are covered in AP Physics 2 and AP Physics C. Okay, which I might teach next year. Okay, so I want you to describe when. What happens when I close the switch? Oh, sir, I don't know how the refund works, but I mean, I personally just don't think it's worth it. It's just more stress for something that has zero payoff. Like if you get a 5, hey, just like how our bulbs are 25 watts and 40 watts, if you get a 5 on the exam, it's gonna be a 5, okay? I want you to think here. Here's our goal. My ultimate goal is to, okay, yes, Jacqueline. We can wait. Why does the current know the switch is open? It doesn't. But well, what if this was a river, Jacqueline, and I dammed this up? Does the water know there's a dam there? No, but it's just not going to flow there anymore, right? It's just all going to divert to this one. It's the same thing, right? There is going to be, if electrons do go here, there's going to be an eventual traffic jam, and there's nowhere for them to go, right? If they keep piling up here, that's impossible because that means this section of the wire becomes negative with surplus electrons. That can't happen, right? Because all elements of my circuit have to be electrically neutral. Okay, so let me talk about what happens to the, ultimately what I want to say, our ultimate question is about brightness. What happens to the brightness levels of these three bulbs when I close the switch? All right, so what is that really asking about? That's asking about P1, that's asking about P2, and that's asking about P3. How did these quantities change? All right, I think it's really clear to know what happens to P3. What happens to P3? How does the brightness of the third bulb change when I close the switch? Put it in the chat. This one's a freebie. You get a freebie. You get a freebie. You get a freebie. You all get freebies. It goes up, right? Because before it had zero current, after, no matter what these values are, this is going to get some value of current, right? So this will increase. It gets brighter. Yay! Okay, now what I really want to do is to look at P1 and P2, right? So to do that, I want to look at my my traditional three quantities I learned about first, not P, but V, I, and R, okay? What happens to V1? What happens to I1? What happens to V2? What happens to I2? All right. And to do that first, let's talk about, before you answer any of these, the thing you have to answer first is R total. When I close the switch and include the third bulb, what happens to the R total? Whoa, 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 freeze. Before you answer that, everyone look at what Sarah just said. She says I2 decreases. I2 decreases. That kind of makes sense, right? If I close the switch, all the current, instead of going all there, will split. But what is Sarah, and you can answer this yourself, Sarah, too. What is Sarah failing to take into account? I2 will only decrease if what is true about I1 when I close the switch. There is a critical premise we are ignoring. I2 decreases when I close the switch if and only if something remains true about I1. Yes, if I1 doesn't change and I add an extra branch, well then, of course, I2 is going to decrease. Or, what's the second way? I1 doesn't have to stay equal. I1 could also decrease. If I1 decreased and I have to split it, then I2 is less than before, right? Okay, those are the two options. So if I1 remains constant or decreases, then I can say I2 decreases. But guess what? I1 can also increase. So I don't know. I don't know which of those three things I1 does. Does I1 increase, decrease, or stay the same? Because I don't know, I can't say for anything about I2 yet. So how do I know what to do about I1? That's why I'm solving for R total. I hope we can see the connection between R total and I1. And if you don't, just start thinking about it. But the first thing I want us to be thinking about now is what happens to our total? What happens to the total equivalent resistance for the whole circuit when I close this switch? Don't type it up in the chat. I want everyone to think about this for like 20 seconds. All right. So if you're watching on YouTube delayed, then just skip ahead 20 seconds. All right. That's enough time to get a very good savory sip. Excuse me. Delicious. All right, 20 seconds have passed. Everyone tell me in the chat, what happens to the total resistance of my whole circuit when I add this third resistor into it, right, with a switch? Chris says, our total. Guys, you don't need to type up super long responses. I appreciate that. You can just say simply greater, less, stays the same. If you want to include the explanation like Chris, that's great. I'm just going to read what Chris says. Chris says, the total must be less than R1 plus R2 because parallel makes it, yeah, I mean, with some tweaks to the grammar, I think what Chris is saying is true, right? If I add the third resistor, then this section becomes a parallel section, and this whole section now has a resistance smaller than that of R2, right? Any parallel section has a smaller resistance than the smallest resistor, or any of the resistors in it, right? So because this section now has a resistance smaller than R2, and before R2 and R1 was in series, and now I have this parallel section in series with R1, the total resistance has now decreased. All right, so I'm going to write that down. The total resistance went down, it decreased. Does that make sense, Yona? For those of us already thinking ahead, I wanted to ask about our total, not because I care about our total, but because what I really wanted, the crux of this problem hinges upon I1. So how do I connect our total to I1? Chris made a cool statement. This means total I increases, right? If total R decreases, just by using V equals IR, if I treat these as totals, if the R decreased, that means the I increased, right? So, and the total voltage never changes, right? I'm not changing my battery, right? So how much I lose after I gain that in the battery is always going to stay the same. So total current increases. How do I connect that to I1? Chris just made this general statement. Total I increases and I1 increases. Well, how do I know that? What is the connection between total current and I1? It's obvious to many, but it's not a fact we should be taking for granted. What is the connection between I1 and the total current? I1 happens to be equal to the total current because everywhere where I have purple is where I have the total current, right? Anywhere where my current is concentrated in one branch is where I have the total current, right? All right. Wow. Can we start thinking ahead? Don't put it in the chat, but I want you to think ahead. Why don't I want you to put it in the chat? Because even though you're super excited like I am, don't want to spoil it for other students, right? Okay, so if I1 increased, what's the next thing we can say? Now you can put it in the chat. Between V1, V2. Okay, so freeze. Don't put it in the chat. Don't put it in the chat. Freeze. Okay. Remember what we said about I2. I can only say decreased if I1 decreased or if I1 stayed the same. I1 does neither. I1 increases, but does that mean I2 increases, stays the same, or decreases? We don't know anymore, right? Because on one hand, we have I1 increasing, but now we have to split it. So it's like going from like a personal pizza and eating it all by myself, and then ordering the next size up, but now having to share the pizza. I really don't know if I'm gonna get more pizza than before. It just depends on how I share it and how much bigger the pizza becomes, right? So we don't really know what happens to I2 now. So we still have to talk about, and if I don't know what happens to I2, I don't know what happens to V2. So the only thing I can really say now with certainty is what happens to V1. So put it in the chat. What happens to V1 if I1 increases? Chris says it increases. What does everyone else say? V1 increases. Okay. You are correct. V1 also increases, right? Atune says it increases. Bonus question. Did you? Why does it increase? Since resistance is constant, but what else? What law am I in? Yes, Ethan. Yes. Okay. Pascal, are you in the chat? Zakharov, are you in the chat? Where'd you guys go? Marcelo, are you still in there? Ohm's law, right? Because V equals IR, and I said R is constant, right? I increased, that means V increased. All right. Wow. We're all. Hey, Ethan, say hi, okay? I miss you. I miss seeing your faces. We're gonna have a Google Meet soon, okay? All right. Now we can start talking. V1 increases. V1 increases. What can I now say? What can I talk about? Can I talk about V2 or I2 now? I think I can. Let's take a rewind, okay? And talk about how we got to this point, all right? R total decreased. That allowed me to say I total increased. That allowed me to say I1 increased. That allowed me to say V1 increased. Now what can I say about other things? The only thing left to talk about is V2 or I2. If I know V1 increased and this battery is the same, what do you think I can talk about next? Who's having a light bulb moment right now? Get it? I can talk about V2. Ayanava, I'm going to follow up on you. Why does V2 decrease? Or anybody else for that matter. Thank you, Chris. I thought that was a pretty good joke. TBH, okay? We're going to stick with 3-letter abbreviations. So I'd like some LOLs in the chat, but I also want in the chat for people to expound upon what Ayanava is saying. If V1 increases, why do I know V2 decreases? There is a rule I can reference. Justin, that is so good. How do I make you a moderator? Wow, +1. All right, enough with the LOLs. If V1 increases, why can I say V2 decreases? We're almost there. We're halfway there. Not really. It's more like 80%. Yes, the loop rule, right? If I gain some voltage here and I lose it here and I lose it here, right? If my drop increased here, then the drop here has to decrease because their two drops have to equal the same value because the battery is the same. But be careful. We're not talking about V3 at all. Because like Sarah said, in our loop, the only thing I care about in my loop is that. My loop is blue, right? It's just this, right? So let's put in some fake numbers, right? If this was a 100-volt battery, and before it was 40 and 60, right? If V1 increases, even if it's a little bit, if it's 41, guess what this is? This is now 59, right? Due to the loop rule, right? So now I know V2 decreases. So what happens to I2? Huh? Jacqueline, what rule are you using there? Anyone else in the chat? I2 decreases. Jacqueline, you jumped the gun a little bit, huh? It's okay, right? I do that all the time. You guys have seen my errors on the board. Ohm's law, right? If V equals IR, and I know V2 decreased, R2 remained the same, I2 decreases. Now I can finally start talking about what happens to the power, right? Power 1 increased, power 2 decreased. So if you were to do this, as soon as I close the switch, this gets brighter because it wasn't even turned on. This gets dimmer, this gets brighter, regardless of their resistance values, right? So this has nothing to do with the do now. Like which resistance was bigger, I don't care, right? I don't care if this was like 50 ohms and 25 ohms, or if this was 25 ohms and this was 50 ohms. No matter what the resistances are, everything we just solved for is going to be true. So no matter which one's brighter to begin with, so even if this one was dimmer than this one to begin with, as soon as I close the switch, it gets even dimmer. And this gets even brighter, right? So, but from our original problem, do we know if this will be dimmer than this one? If these will be equal, or if it'll still be brighter? We don't know without actual values, right? But what we do know is that compared to what it was, just compared to itself, it'll get dimmer. Compared to itself, it'll get brighter. Compared to itself, this gets brighter. You can construct this very same circuit in the FET simulator and see for yourself. As soon as you close the switch, you should be able to see everything that we just predicted. Okay? Now, traditionally in class, I usually give the assignment in a paragraph length response. Explain why this bulb gets dimmer. And you're going to have to cover this, the R total, I1, V1, V2, and I2. Right? That's the way you have to going to go about it. And not only, and you're always going to have to talk about why and which formula you're referencing, right? So why does I1 increase? Because it's the same as I total. Why does V1 increase? Ohm's law. Why does V2 decrease? Loop rule. Why does I2 decrease? Ohm's law, right? That's like the thing you really got to be thinking about. And if you can do that, let me amend my previous statement. If you understand this, maybe you understand everything about circuits. If you can write it down in a paragraph length response with like proper explanations, then I can say you fully understand AP's Physics 1 level circuits. Okay? Cool. So I will leave that as an optional assignment on Google Classrooms. If you want feedback, I will read them and offer feedback and tell you what you're missing. Like, oh, that claim didn't have enough of a justification or an explanation, right? But yeah, so I'll create that on Google Classrooms, and that's about, whoa, my laptop almost fell. Okay, so that's about it, okay? If there are no other questions, that just about wraps up circuits, which is cool. Tomorrow, we're going to be starting magnets. I guess we'll get super pumped about magnets, okay? And with that, I will bid you adieu. Have a wonderful day. Today's Wednesday, guys. It's hump day. Get pumped, all right? Bye, Diman. So good to see you. See you. 40 watts. AP exam. Hi, Sylvie. Bye, Sylvie. See you guys.